Hey, good morning.
Sorry, I'm recording.
It's all good. Hey, good morning, everyone. As Tom said, my name is Jake. My name is Jake Worth, and I'm here today with my um, former colleague and longtime coding associate, Jack Christensen. Um, you can see on one of these many screens. How big a cohort do we have today?
We have 22 students, plus we have 5 TIA interns. Uh, so yeah, we have about 27 or 25 total online right
Okay,
now.
okay, excellent. Well, I'm going to switch over to the repo that I posted in Slack because that has the um, plan for the day, and that's where we're going to spend most of the day. So let me just share my screen if I can do that. Okay. Can everyone see this terminal? Tmux.
Yeah.
Okay. Is it readable? I'm on a laptop screen. Maybe a little bigger.
It's solid on this end.
Is it yes or no? Sorry.
Yes.
Okay. Yeah, so this is a README for our repo, and I'll just start off by saying that everything we're going to do today is going to be using Postgres. Postgres is the database that we probably know the best. I know that you all have installed it, or it's an it's an important part of the curriculum. So if you can type PSQL in your terminal and you see a prompt like this, that is good. And if you're not there yet, our goal is to get you there, early in the day so that you can follow along with all the stuff that we're typing. So I'm going to be talking for a bit, and um, but after that, I'll be totally free to help anybody install Postgres. There's a homebrew package, there's Postgres.app, and there's apt-get if you're on Ubuntu. So there's like many different ways to do it, and that kind of complicates it because I don't know the way that you're trying to install it, but I will do my best to assist. Um, so this repository I posted in Slack, you're going to want to clone this down and cd into it, and make sure you have psql installed. Okay. Um, so in this directory, we have an agenda, and so let's start talking through that. 9 a.m., 10 Eastern. Oh, sorry, yeah, 10 o'clock Eastern. We're going to start off just getting to know each other a little bit, and then I'm going to review the database reading. After that, around 9:45, 10, probably more like 10, we're going to start working in the Postgres REPL and typing in the commands that we're going to be learning today. I put some like general advice here that I'll cover this maybe right at the beginning of that session, but this is just stuff that we have learned from many many iterations of teaching this course and learning SQL stuff ourselves. Okay, so we're going to go through Postgres. We'll go all the way to lunch just typing in SQL. And after lunch, we'll pick back up. At 3 p.m., we're going to do a data modeling exercise, and we'll stop around 4 o'clock for Q&A for Jack and myself, and then we'll be finished around 4:30 and back over to your instructors. So one thing I just wanted to say on the top of the day is um, Jack and I have been doing this a long time, as Tom mentioned, and uh, we would love to answer questions that you have. Um, a lot of what we've done now has been recorded. You could watch it on old videos of Code Platoon or possibly on YouTube. So I think what makes the day special, or what is unique, is that we can answer questions. And if you have a question, it's a why question about anything we're doing. A lot of this stuff is old. There's a lot of history and backstory to it, and there any question you have is probably a good question that other people are wondering too. So please feel free to ask questions all throughout the day. We'd love to answer your questions. Okay. Let me just start off by talking a little bit about who Jack and I are. We have a lot of people on the call today. We sometimes kind of go around the group, but I know you guys have done that many a time, and also there's a lot of people. So if you wouldn't mind just sending me a Zoom message in the chat, like with your connection to the military, and your thoughts on Sql if you want to add some color sometime this morning. I'll start off introducing myself. My name is Jake. I am a software engineer at FrameBridge. I previously worked at a company called HashRocket with Jack for 6.5 years, and they were the people who started facilitating this course, and they're kind of the reason our CEO Marion's support of Code Platoon is the reason that Jack and I are both here. And in my previous life, I was in the Army. I was an armor officer, deployed to Iraq in 2006 and 2008 with tank platoons and scout platoons. And I'm really, really excited to be here today. Jack, would you like to give us your introduction?
Sure. So I've been doing development stuff since even before I got out of high school, but I've been doing it for a couple decades now. Been doing Postgres for probably about 13, 14 years. If you use the Go language, you're probably using code I wrote if you talk to Postgres, because I'm the maintainer, the creator of the Postgres database driver for Go. So that's some of my experience on that front. Like Jake said, we worked together at HashRocket for years, and Jake was kind enough to invite me along for the first platoon, for Code Platoon. We've been working together ever since, and hope we're able to provide you some benefit this day.
Cool. Any questions so far? Okay. Yeah, so just send me a message telling me about yourself. I promise I'll read them all. And let's get into reviewing the reading. So I have some slides that I made. And are you all seeing a big slide now?
Yes.
Okay. All right. So the reading that I think you're still being assigned is called Intro to Persistence. If not, that's the name of my talk. So here we go. Okay, so for the next probably 40 minutes, I'm going to be talking about databases and persistence. And as I said before, if you have questions, I can't really see anybody right now, but just feel free to ask. And we'll stop for questions at the end too. All right, so we're going to start off today talking about the database reading. This is all, this part of the day is pretty conceptual. The rest of the day is pretty practical. We're just going to be typing SQL, but this is like the theory of what we're doing. So I'm going to start with a opinion that Jack and I share. I think that it really colors everything we're going to say today. Databases are important. Databases have a lot of business value. Databases can be very sensitive. Databases will probably outlast all the code that you write for the application. You'll rewrite the front end, you'll rewrite the back end, you'll change your mobile app, but the database will persist and outlive all of those things. So we come from a position that databases are really important, and that's why we're excited that we get to teach this to Code Platoon, each cohort. Okay, so we have 4 agenda items. The first is persistence. We're going to talk about what persistence is and why you might want it. Second, we'll look at a common persistent solution, the spreadsheet, and we'll find out why it doesn't really support web development. Third, we will talk about relational databases, what they are, why you'd want them. And last, we will explore the features of a RDBMS, the Relational Database Management System. And this talk is going to be about 30 more minutes. Okay, part one, persistence. Would anyone be willing to offer up a working definition of that term?
Just not giving up.
Not giving up. I love it. That's great.
Around after our active program is gone.
Yeah, can you say that again?
Data that hangs around after our active program is gone.
Yes, those are both great answers. I laugh because it's rare that I get like a surprising answer to these questions, but it's a really good one and very true. But I think in the context of computer science, we're talking about something staying around after the program that made it is gone. This is the dictionary definition: continuance of an effect after the cause is removed. And this kind of alludes to a big idea in computers that data is transient. Right? Data only lasts as long as we tell it to last, and it doesn't last a second more. It doesn't have any concept of sticking around on its own. And there's two concepts that I think of when I try to explain this. One is scope, right? So we see this in a programming function called scope. If you look at that bullet point, there's a anonymous JavaScript function that takes an argument A and an argument B and adds them up, A and B. When the function is invoked, A and B means something, but as soon as it's completed and the addition of A and B is returned, what happens to those two things? What happens to A and B? Well, in a language like JavaScript, they're not needed anymore. So eventually the program comes and cleans them up through a process called garbage collection. So the scope that they lived in is eventually destroyed, and A and B don't exist anymore. They're gone. The other concept I think of is memory, like RAM on your computer. It's holding a lot of information, but if your computer loses power or you shut it down, all of that information goes away because the memory isn't designed to persist that information. It's just temporary. So basically, my point here is that data in computers is just always going away, and if you want it to stick around, you have to explicitly tell it to stick around. And there are a bunch of tools that have been developed to support this. The first is the database, which some people call a data store. Then we have the primary language for talking to databases, structured query language, SQL. So I call it Sql, but some other people don't. And then we have the Relational Database Management System, which is like a collection of tools that support the database, that are more than the database. And then last we have ORMs, Object Relational Mappings. I think you all get into ORMs a little bit later. Is that right? I don't think that's quite happened yet.
I think it's coming next week.
Okay. We're going to talk about ORMs a little bit today, incidentally, but they're not really a focus of our presentation because they're an abstraction. They're, in the end, an ORM is an abstraction of SQL. Is that a term you all have encountered yet? Is anyone familiar with that term?
Yes.
Cool. Yeah. So an abstraction, it's a representation of the talking to the database. The SQL is the actual talking to the database. So Jack and I have sort of an opinionated stance that we want to teach the SQL to you, and then you can learn the ORM, and they're a very important part of being a developer. Very important. But I think I think there's a lot of value in understanding the SQL. Yeah, some people might call an ORM an API for talking to the database. So they're very important, but not the focus of today for us. Okay, so next I want to talk about a way that you could store data, and that is a spreadsheet. Always have some analysts in the class or some people who are really good at spreadsheets. Much respect. Do we have any Excel experts in the group?
I've done some things that should have been done inside of SQL with spreadsheets, but yeah, I'm not proud of it.
Okay.
I've made some rather expensive spreadsheets before for a personal project.
All right. No hating on Excel. Some people call Excel the world's most popular programming language. So to understand what a database is or why it exists, I think a useful way to think about them is from the angle of a spreadsheet. Because the database was the answer to things that already existed in the world, and it was really the answer to this concept of a ledger, the modern version of that being the spreadsheet. So I have this book that I bought and stored in the library of the Hash Rocket office in Chicago where I used to work. It's called the Manga Guide to Databases. Right? It's this.
That's adorable.
Well, it was the first book I think I ever read about databases, so I recommend it. It's a funny book, but if you happen to pick it up, it's set in this magical kingdom, which is the castle in the background, and the kingdom is trying to design a system to track its economy, which is a fruit business. And the fairy on the cover is this magical fairy who tries to teach the kingdom how to organize their business data. And the fairy, well, they start off with the ledger, which is that brown book. So what this book kind of does is it presents this thought experiment that a lot of people learn when they're learning about databases, where you work step by step through starting with a ledger and seeing its weaknesses, and eventually arriving at something very much like a relational database. And that goes back to what I was saying a second ago. The database is an answer to things that already existed, and looking at a spreadsheet gives us a compelling clue to why databases exist at all. So this is just a really random spreadsheet that I downloaded off the internet, value investing spreadsheet. What would be like a job title of somebody who would use this, like on a daily basis?
An accountant, possibly.
Accountant.
Yeah, accountant, sure. Analyst, perhaps. Now, this you can do a lot with this spreadsheet, but as a data storage tool, what is missing from this, and how does it? Can we imagine ways where it would fail to be useful? That's sort of a hard question, but
it misses historical changes. Like if you change a block, you don't know like what it was previously.
Yeah, right. You can change any cell, and I don't know how far Excel has come, but the Excel that I was familiar with, that was kind of like that information was not exposed to the user that I changed this cell. When it was changed, how you changed it, that's just all like hidden. So yes, that is one thing. You don't really have any concept of who changed something and when they changed something. Other things that could be missing.
I guess the way it's shown, it's pretty much everything is thrown together. It's not really separated in almost like an OOP aspect, where instead of having all your data tied together to each other, having it separate in like another Excel sheet, for example, and having it accessed through like a unique ID.
Yeah, that's a great point. The data is a perfect it's perfectly organized the way that it's stored, at least the way we would think of it, right? Like if you want to change cell C121, there's only one way to do that. You have to click on cell C121 and change it. You can do things with like pivot tables, and you can you can make it, you can bend it, but um, the spreadsheet represents the data as it is. There's not really like another way to look at it. Great
If
point.
you're
Others?
Why there's no flexibility in it.
No flexibility. Yeah, it's really rigid. I mean, it's just a bunch of columns and rows.
I figure it'd make it hard to cross-reference anything.
Sure. Yeah, I mean, I'm sure that there's cross-referencing. Talk a little more about that.
Well, I can't really tell what the purpose of the database is, but if you needed to find something with a specific property that matches something else, that would be something that a database could help you find a lot easier.
That's a great point. Yeah, it's not very searchable. If you want to find something that happened, let's say you want to find whether the data that's stored inside cell B120, where it says 690 cash on balance sheet. How would you do that? You'd have to know the cell that it's in, or you'd have to know the value that it is. That's really kind of the limit of the searching that I know how to do. Yeah, these are great. Others?
You can't drill down to find any detail.
You can't drill down for sure. Okay. You all got most of the things I would say, just to kind of like run down the list. Okay, 2 people using it at once. Does that really work? I don't know how Excel handles that anymore. It used to be that it would lock you out if somebody else was working on it. So it doesn't really support 2 people working on it. It definitely doesn't support 20 people working on it. Even if it could, the program will probably crash. Is it very fast? It's not that fast. Excel is not going to be as fast as a something running on the command line. No matter how fast they try to make it, it's not going to be as fast as something. It's not going to be as fast as a process running in the background, because it's got this beautiful GUI, the graphical user interface we're looking at. So searching, we talked about. Presenting the information in a useful way. I wouldn't call this very useful. It's like all the information on one giant page. It's hard to restrict access. I don't know. I see a protect sheet little thing there, but I don't know how like specific the ability to restrict access is. We don't know what's being saved in every cell. Here's another one. You can't really. It's pretty hard to control what gets saved in every cell, right? Like if I say I want column 119 with those years, I want that to only be years. I don't know if Excel supports that. It's not something that most people do when they make a spreadsheet. Most of the time, you can put anything into a cell, and you see the the consequence of that a lot of times when like the addition or the equation that someone has written, like it's basically like not a number. Okay, there's a lot more.
To jump in on one of those examples of people using spreadsheets when they shouldn't, within the last year, there was a story from the UK that one of their health departments used a spreadsheet to track COVID cases. And mysteriously, it turned out they had exactly 64K cases, because the way they were saving it, they used like an older Excel format or something, and it just trimmed off all the rows after 64K. So that's another example of you can have databases. Postgres can handle databases in the terabyte, tens of terabyte ranges, But you try and get a spreadsheet that's, a gigabyte is a small database. You try and have a gigabyte spreadsheet, and well, good luck.
Absolutely. So the types of things you store can't really be controlled. It's pretty hard to validate. Like, what if for the year column, what if I don't want to allow anything before 1990? That's not built in. That's not something that Excel does very easily. What happens if this file on the computer gets corrupted? It's very centralized. It's on somebody's computer, and if that computer goes down, you're in trouble. There's the cloud version of Excel, which did sort of solve that, but classic Excel, that was a problem. What if we want to connect to this database remotely? That's not something that Excel has built in. If I put this on a server and you want to connect to it, how would you do that? So this is a lot of things that the spreadsheet doesn't do very well, and all of these things are coincidentally very important for web development software. This data is really important, but we're not given. There's a bunch of tools that we don't have that we would probably want to have for it to be a real solution to support like a web application or a mobile application. And this is why spreadsheets are not the way that data is really stored for web apps. There's a little exception to this now, where there's like some of these serverless solutions like Airtable that are kind of like filling a gap where some things can be sort of like a spreadsheet, but that's definitely the exception to how this is done today. It's not the standard way. Most web applications are going to have a relational database behind it. Okay, so hopefully that exercise showed a little bit the value of a spreadsheet, the value of a database, and hopefully you're somewhat interested in what a database is. So if I've sold you on databases at all, the next question is, how should a database be designed? The solution that we're going to cover today and you're learning first is the relational database. And every time, often when people are introduced to relational databases, they ask about the alternative, not relational databases like NoSQL databases, Redis, and Mongo. And those databases are really popular. They are used heavily in production. They're tools you might choose to learn, or get an opportunity to learn in your first developer job. But there's a reason to start with relational and put a lot of energy into learning relational, in my opinion. And this illustration hopefully will help. So this is the Stack Overflow Developer Survey from 2019. And what this is showing is it's showing the most popular databases when users were given the option to select all that apply. So in first place is MySQL, second is Postgres, third is Microsoft SQL Server, fourth is SQLite, fifth is MongoDB. So the top four are MySQL, Postgres, Microsoft SQL Server, and SQLite are relational databases. Only in fifth place do you get to a not relational database. So it's definitely, I think it's really fair to say that relational really does dominate as like the main persistence database for a web application. Relational dominates, and it has for a long time. So although alternative databases are really important and have a place, it's kind of our approach that it's really good to learn relational first. And you might be wondering why. Why is this pattern so popular? And I think the reason is that relational databases really line up well with a couple of important ideas in programming. The first is that users should not know how the data is organized. And this is like a security, just kind of best practice. If you think back to the spreadsheet, what is if someone wants to edit a cell on the spreadsheet, how do they do that?
Just click and edit.
Right, yeah, you click the cell and you edit it. The interface to edit this data is the spreadsheet, and it is Microsoft Excel itself. The software itself is the form. When data is organized that way, the interface that you use to enter the data, it pretty much perfectly represents how the data is saved in the database. And on the web, that is not ideal because sometimes we don't want the users to know how the data is represented in the database. Whenever information in an application is given to a user that you don't want them to have or you don't intend for them to have, people call that leaking. You're leaking information. And a spreadsheet is basically 100% leak, because if you can see the spreadsheet, you know how the data is stored. And that's just as a principle sort of undesirable. The second idea is user activity should remain unaffected when the internal representation of the data is changed. Let me say it. I need to rewrite the sentence. User activity should remain unaffected when the internal representation of the data is changed. So think about a company like Facebook and try to imagine how their data structure has changed in the last 15 years. It's pretty likely that how a user was represented 15 years ago and how a user is represented today has probably changed really dramatically. I don't really know, but it was probably a very simple model before, and it's probably a very complicated model now. But as a user, your experience has mostly just kind of trudged along and hasn't really changed. And Relational is really good at supporting that goal, which we'll see here in a second. So let's look at a relational database structure for an application that I worked on quite a while ago now. This is a website that some coworkers and I built for HashRocket called Today I Learned, and it contains small posts about technology. So this is something called an entity relational diagram, entity relationship diagram. It's like a PDF representation of the data structure that, and Ruby on Rails has a library that can generate this. I would imagine Django has something similar. So let's say, just to cover the data model real quick, there's only three user created tables. There's the developer table, there's the post table, and there's the channel table. And these arrows represent the relationship between them. So a developer has many posts, and a post belongs to a developer. A channel has many posts, and a post belongs to a channel. So that's like all the relationships in this fairly simple application. So let's imagine that we needed to make a form for entering a new developer into the database. All right, so what is a developer in this app? You have like, are they an admin? That's a Boolean. Are they editor string, email string, Slack name, Twitter handle, username? Those are the columns. If I wanted to make a form to enter a new developer, do I have to expose anything about channels or posts?
I'll say no.
I think the answer is no, because a developer has many posts. They might not have any posts. And channel isn't even, there's no line between channel and developer. So you don't need to have a post, and therefore you don't need to have a channel. So you could make a form for a developer that's basically just this basically just that rectangle for developer, and it just asks for those fields, and it might not even ask for all of them. I'm not going to let them say if they're an admin, but I might not ask their editor. That might just be a default value. I might not ask their email. I might only ask for their email, and I don't set anything else. So, if you showed that form to a user, would they be able to draw this map? I would argue no, because all that they see a form, and all they see is email. They don't know about any of these other columns. They don't know about posts, and they don't know about channels. If I add a column to the developer table, does the user know about that? Maybe not. The column might be it might be an optional field, or it might be something that I set on the back end, and they never see it. I might say IP address of the developer, and I just record that, and I never even tell them that they don't know that was even saved. The relational database model is really good at that second thing, where the user doesn't know that the relation that the structure of the database has changed. There's a lot more we could talk about on this little table, but I'm going to keep going unless there are questions. Okay, one more thing I'll point out is that there's really no redundant information on here. If you look at a channel, the little channel rectangle, it has its name and it has a Twitter hashtag, and that's all that a channel knows. It doesn't know about posts, and it doesn't know about developer. Now, the way that relational databases work in Rails, there are two columns that are not shown in this diagram, where a post will have a developer ID and a channel ID. Entity relationships don't show that because they choose to show it instead with these arrows. But the post knows about the developer, and the post knows about the channel because it belongs to both of those tables. But the other tables, they don't. A developer doesn't know about a post in the data layer. So there's really not much redundant information here, and that's kind of the goal. A couple of quotes that I think are really relevant to thinking about this from a Ruby programmer I like, whose name is Sandy Metz. Sandy has said, always delay making design decisions until you need to. And when you all get into your projects, you may get a chance to exercise this advice, or you may not, because I know that time goes by really fast. But we keep the tables separate because we don't really know what the final design is going to be, and we might want to rearrange the pieces. We might want to say, a developer is related to a post through some join table that we haven't thought of yet. And relational really lets you delay making design decisions because the tables are kind of like blocks that are connected to each other, rather than a giant wall of data like a spreadsheet. Another Sandy quote that I like is, we'll never know less than we know right now. When you're first building an application, you basically don't know anything. And as you go along, you gain knowledge that leads to the final product. Relational gives you the freedom to slowly add and build, rather than committing to one large data structure, from the beginning. Okay. For the last part of the talk, we're going to discuss the features of a relational database management system. I'm going to kind of go through this a little more quickly because the rest of the day we're going to be using a relational database management system, and that's more fun. So these are the tools that a relational database management system provides. So you have the CLI tools, the stuff that lets you connect through your terminal or connect via a remote server. You have scaling, which is we talked about with the spreadsheet kind of. Actually, we didn't really talk about that, but it's a little bit lacking. Data validation, data integrity, and searching. So to briefly talk about each. So this is a representation of that channels table we looked at a couple slides ago. This is the Postgres representation, and there's a lot of information on here that we will be like diving into throughout the day. But this is how Postgres actually saves that channel. So you see you've got an ID, and that's going to be incremented for us whenever we create a new record. You have the name and the Twitter hashtag. Those are the two columns that were actually on the chart. And then inserted at and updated at are two like database controlled or Python, Ruby, depending on how you set it up, controlled values that just kind of tell you when something was created and when it changed. So the CLI tool we're using to view this is called pSql, and that's the one we'll be using today. And with pSql, you can run a command like this, /d, I think stands for describe, describe the channels table. So the CLI tool gives you the power to look at any tables, and it gives you the power to run queries and much more. Next, we have scaling. So relational database management systems are designed to allow multiple users to query and update records at the same time, so our programs can scale. Postgres is great with this, where it really defines a system for multiple people using the database at the same time, and it gives you like very fine-grained control, something I think that Jack is going to be talking about somewhat later on today. We want the database to be accessible to as many people who need to connect to it as might want to connect to it. So the mobile application, the desktop application, we don't want any limitation there. Data validation, right? So we can validate records and relationships. To go back to this column, I think we have a constraint on here. Yes, we do. So if you look at the bottom of the table, it says reference by. That is a constraint. Table posts. So another table we don't know about, table posts, has a constraint called post channel ID F key, foreign key. That's just how it was named by, I think, Phoenix, the Elixir MVC library we used. It has a foreign key channel ID that references ID on the channels table. I'm moving my mouse. I know you all can't see it, but I'm just reading the bottom line of this thing. Channels.
I can see your mouse.
Oh, awesome! Much better. Channels ID. So what is this trying to, on delete cascade? So what is this saying? It's saying that there's a table somewhere called posts. It has a constraint with this name, and it's a foreign key constraint. So that table has a column called channel ID, and it's a foreign key constraint. So it expects there to be a table called channels. Well, here is where we see that. It references that ID on that channels table, and on delete cascade. So if you delete the channel, it'll delete the post, I think. May have that backwards. Right.
I believe that's right.
You want to delete the post table without deleting the channels table.
Well, specifically, we talk about records, just to clarify. So what would be the bad situation, right, would be that a post says my channel ID is number 10, and then there was a channel with ID 10 and we deleted it. That would be bad. And that's what this constraint exists to protect us against. So the way that I would want this to work is that when I delete the channel, the post also gets deleted, because I don't want that post thinking, hey, I have a channel ID 10 and that channel's gone. We call that an orphan record, and it's and you write constraints like this specifically to try to prevent that from ever happening. So that gets us back to validating records and relationships. So then we get data integrity. Database systems give you something called transactions. Transactions is a block of logic where you're basically saying, if one of these things fails, undo them all. And the canonical example of that is bank accounts. If I'm transferring money between two accounts in my bank software, if I take the money out of account A and then I try to move it into account B and that fails, I want them both to be undone, because it's obviously a really bad situation. If you took money out of one account and you didn't put it into another one, that money like just vanished into the air. So databases provide a mechanism to support that called the transaction. And yes, preventing unintentional changes to information is another concept of the data integrity feature. And searching. This is what we'll be doing a lot of today. You can return records that match multiple complex criteria. This is one of the coolest things about relational database management systems is you can write many different kinds of queries that give you anything you want to see, which is really cool. Okay, so what has this hour brought to us? We talked about persistence. Then we talked about a common persistence solution / anti-pattern called a spreadsheet. We talked about relational databases, and we talked about relational database management systems. I guess sort of to summarize, persistence is crucial to software. Relational databases are a very popular solution. And Postgres is a very good relational database management library, and it's one Jack and I have invested a lot of time in learning. So I'm really glad that you all are learning it too. And from here through until the data modeling exercise, we're going to be using Postgres and typing SQL queries. So that's a lot of information. Any questions at this time?
Yeah, I do have a question, but it's kind of semi off topic.
Go for it.
So I think it was like 2 days ago, I went down kind of a security rabbit hole on YouTube. Basically, the gist of it was talking about defensive coding, and I guess for like databases. So how do you normally approach that when it comes to, I guess, like defensive coding, like, keeping, malicious actors from doing like SQL attacks and stuff like that?
Interesting.
I'd like to answer that.
Go for it, Jack.
Okay, so the number one risk with SQL stuff is SQL injection. I don't know if you run across that phrase or not, but the idea there is when we write a SQL query, we write something like select star from users where such and such. And we'll say the such and such is email equals something the user typed. Well, if we do not properly handle that user data, maybe they do something like they type their email address as, John@example.com, then they put a single quote, and then they start typing some SQL command. The single quote, if we just naively interpolated the user input directly into the SQL string, they could trick us into executing whatever code they typed in. That's basically the number one attack that happens that relates to SQL, is SQL injection. And the answer to that is twofold. One, there's something called prepared statements, where you can say, this is a command I'm going to run, and I'm going to put placeholders in for the data, and then I'm going to supply the data separately. That, when you use those, the database engine itself guarantees safety. The other is, if for whatever reason that's not available, generally any library you use, like Django or Rails or whatever, will handle sanitization of user input automatically if you use its preferred mechanisms. So like in Rails, if you were writing a SQL snippet, you would say like email equals ? And then you pass the email address separately, and Rails would know how to correctly sanitize that data. But the number one thing there is, don't build up SQL strings that include user input. That's like the number one security concern with SQL.
Right. Does that make sense to everyone? Like, if you have a form on your web app and it says, what's your name? And when the person submits the button, it posts to an endpoint on your Django application. Like, don't take that string and interpolate it, and don't interpolate that into a string and then execute it as SQL. That's the SQL injection risk. And if you have good tooling, it should be screaming at you that that's like a terrible idea. But when you're just getting started, you might, or when you haven't like using a new library or something, you might not get those kind of warnings. But that should be like a red flag always, that taking raw input from a user and executing as SQL is like the definition of SQL injection. I think somebody posted about that in general or Oscar Platoon channel. The like somebody, your son put his name on this form as like delete from users semicolon, right? That's SQL injection. And if you go to a web application form and you type in delete from users and hit enter, if they're vulnerable to SQL injection, you might actually be running raw SQL and you could really mess them up. Did we answer the question or more there?
Oh yeah, you did. Like I said, it was kind of off topic and it was just down a rabbit hole. It was mainly because I was thinking of how to defensively code against it. Like there's always a possibility of someone trying to do something you don't want them to do. And so I was just curious on your input since you've been doing it a lot longer.
That's a good question. Yeah, I'll also say the term defensive programming has another meaning that you all might have heard. I just wanted to like disambiguate that. Some people use defensive programming can also mean code that's worried about things that are unlikely to happen. It's kind of like a criticism of code. If you're writing code that's protecting against something that's like impossible or very, very rare, then some people would call that defensive, and they'd be like, you shouldn't be doing that. That's bad. But I think in the context of this video and the rabbit hole you went down, it's talking about just general security, having a secure web app, and that's always good. Always want to have security. And as Jack said, the biggest risk is SQL injection, because you are letting your user, if you do that, you're letting your user run queries on your database, and we don't want that ever. Other questions? Okay, at this time, I think we're going to take a break. let's meet at 10 after, which I'm on Eastern time, so I'm going to be saying this wrong all day. Is 10:10,
Yep.
and we will be setting up for the SQL portion. If you're having any problems with Postgres, I'll stay online for this time and just send me a message and try to work through it, and we'll get started then.
So for this this section, like Jake said, we're going to be pretty much entirely in the Postgres command line. So I'm going to share my screen here. All right, can you see my VS Code window here?
Yep.
Yes, sir.
Cool. Okay, so I'm going to use the terminal in VS Code. Normally I use a separate terminal, but for ease of screen sharing, I'm going to do it all in line here. I don't know if that's what you all usually do or if you use a separate terminal. Either one should be fine. So to start with, does everybody have this repo, this SQL Workshop repo checked out?
Yes, sir.
Cool. Okay. So we are going
Jack,
to go ahead.
Would you mind zooming in a little on your VS Code window so it's easier to see?
Sure, that's a great idea. Let's see here. All righty. So we are going to change to the phone book directory. And you're going to want to open up lesson.sql in the phone book directory. We're going to start here. Let's do this first two steps here, then we're going to talk a little bit. And basically, every time Jake and I have taught this, we always have one or five or whatever, a handful of people that their Sql prompt, just for whatever reason, does not want to cooperate. So let's do these first three steps here, and then we're going to pause for a bit while I talk a little bit. And while that's going on, if anybody has a problem, if you can message Jake, and hopefully we can get everybody connected here. Because if your Sql prompt isn't working, it's going to be a pretty long day.
Yeah, Jack, I said I would go through the guidance in that agenda before you started, and I completely forgot about it. Should I talk through that real quick?
Yeah, sure.
You don't have to change screens or whatever. Just let me in the agenda. A couple of just tips here. Is the first one is if you can, try to type out the commands today. Jack's going to be doing a little bit of copy pasting later on because he's going to be running like really big queries that would be very boring to watch somebody type. But building muscle memory right now is really good. And we can demonstrate some ways to make that work even better with tab complete and such as we go along. Another tip is make your terminal window as big as you can. Like don't ever be struggling to see the code on your screen. Is something I always try to point out when we're all together in Chicago. Yeah, and if you get stuck, send me a message. And the last one is if you get stuck on these first couple steps, the error message is usually going to be very insightful. So we'll start off with that. If you run one of these commands Jack is talking about and you get a bad situation, sending me the error message would be the most helpful thing. Okay, thanks, Jack.
Cool. So the first command we ran was create DB, and the argument to that command is what do we want to name the database? The next command we're running is this psql -f data context. And you notice that I didn't have to type too much there. Like Jake said, if you're not in the habit of basically mashing the tab button about every third button you hit when you're typing at the command line, then you're typing too much, because tab complete is pretty good nowadays. So you can pretty much anytime you're doing a file path, you can do a tab complete. And many programs like Sql or Git also have tab completion stuff installed. So this command here says we want to connect to the database phone book, and we want to load this data/context.sql. And when I run this, I have a little more output that came out because of I've kind of customized my Sql output. You'll probably see that insert 01, but you won't see the time. And we'll talk about customizing that stuff probably during one of the breaks. It's kind of a random little tricks. Lastly, we're going to type Sql phone book. And we should be looking at a screen like this where our prompt has changed a little bit, and we can start typing Sql. So
I'm sorry, might just be a little bit slow. What was the code after create DB phone book for that printed all the insert and time stamps?
yeah, it is, let's see here. It is this command. It's line 5 of phone book lesson.sql.
Thank you.
So what does -f do?
-f says we're going to, well, okay, first of all, if I just type Sql phone book, you know how it's here and I can start typing things. -f says rather than type commands in, I want to just read this file and execute all the commands inside it. If we look at that file, we can actually see there's a lot of statements that really aren't relevant to us right now. But if we scroll down here, the core of it, it creates a table. And again, we'll talk about what these things actually mean later, but it creates a table and it inserts some rows. We could manually type in all of this and it would work exactly the same, but it's easier just to tell Sql read this file and run it for us. Okay, so I'm guessing, 2 or 3 people are probably, not able to connect to the database if our traditional pattern holds. So like I said, make sure to message Jake while I'm gonna talk a little bit about Sql before we start typing some more. So one of the first things is, like Jake mentioned, we really, really do want questions. We've got more than enough material. We have about 4 lesson segments that we work on. We usually get through 2 of them. So, I mean, we've got plenty to talk about if nobody has any questions. But everything we talk about is stuff that you can learn from books or you can learn from online videos. And while we're here, you've got, literally a combined couple decades of experience. So we want to answer your questions. And if it's a matter of we don't get through quite as much of the lesson, but we answer a bunch of questions, that's a win. We'd love to do that. And like I said, especially questions about why are things the way they are, because oftentimes that's the hardest stuff to look up. If you want to look up and say, okay, I don't remember how to do a left join or something. Well, you can Google left join and you'll probably find something good on the first few results. But if you want to look up, why, some command is named the way it is, well, that's a little harder perhaps to find in the, if you don't know the right keywords to search for. And speaking of why things are named the way they are, Postgres is kind of a pretty weird name, isn't it? I think it is anyway. So just for curiosity's sake, let's talk about that. The reason it's called Postgres is it was a project that was after another database called Ingress. So it is post Ingress was where the name actually came from. So there's a little bit of trivia for you. And as far as SQL in general, one of the reasons, Jake talked a lot about why this is going to be useful from a technical point of view. It's also really useful from a career point of view. You've probably already noticed that there are a lot of technologies that were important basically yesterday and aren't today. And sometimes you wonder, okay, if I'm going to spend all this time studying this thing, I hope I can use it, 2 years from now, 10 years from now, 20 years from now. Well, SQL is one of the more long-lived technologies. It was originated in the 70s and was popular by the 80s. And its original like ISO standardizations, ANSI standardizations were in the mid 80s. It's been revised a number of times since, but it has an extremely long track record, no sign of slowing down. And it's the type skill that if you learn it, you're very likely to get the benefit for many decades. And as an example of that, if you got a SQL book that was published in the mid 90s, 80–90% of it is still going to be useful and relevant. And that's just not something you see with a lot of technologies. So if you're thinking about where do I want to invest, my training time, where do I want to invest, my skill development? Well, SQL, what do they say for investments? Past performance is no guarantee of future results or whatever, but it does have a long track record, and the future looks pretty bright for it. So it's likely that what you learn today will still work in 20 years.
I have a quick question on one of the why questions, I guess.
Sure.
So when starting up SQL, you have to start it up in a database, as opposed to if you were to type Python and go to the Python equivalent, you can just type Python code. Why is it that, because I was trying to, one of the base commands was just to get rid of the database I created that wasn't what I wanted, wasn't where I wanted it. So for this, it's either command line code or you do open pSQL in the database. Why is it that there's no way to open pSQL unless you're in the database?
Yeah, that's actually a pretty good one there. Why? Yeah, I said ask why. That one actually, you stumped me there. I'm not sure exactly why, but that basically is the way it is. However, I guess the answer is there always is a Postgres database, and you can. They got me thinking on my feet here. I'm trying to think of what would be the answer to that. It probably has to do with security, actually, because what database you're connecting to determines what security rules are applied to your connection. We haven't really talked about security aside from the SQL injection stuff, But even just connecting to a database, we're local here, so basically all the security is turned off. But if you try and connect over the network, there's various schemes you can use of username and password or SSL certificates, and various combinations of those will say you can only connect to database X from such and such IP address or something like that. So I think it would probably be entangled somewhat with that. There would also be the question of if you're not connected to any database, what can you do? Guess that's not really that great an answer, but that's all I can really recall and think of on that.
I think that covered it. Thank you.
Okay. Okay, well, I'm going to assume at this point everybody has the ability to connect to the Sql phone book. And we're going to start here with the simplest statement, the one that you use more often, is the select statement. And the select statement starts with the keyword select. Then you list the expressions that you want to get back. In this case, our expressions are simply going to be a comma-separated list of columns. And you say from, and then the table we want to get back from. And you'll notice in the comments of our lesson here, we have links to the Postgres documentation. The Postgres documentation is probably the best open source documentation you're going to run into. It's very extensive. If you actually printed it out, you know, if you get like the PDF version, it's like thousands of pages. So you don't necessarily want to have to read it all. But, you know, a lot of open source projects are not very well documented. Postgres is an exception there. It has phenomenal documentation. So we try to link to whatever we're talking about. So if you want more information, you can jump straight to that spot in the docs and get the details.
What's with the...
Go ahead.
That's all you, sir.
Okay. What's with the ghost text on the right?
Sorry, the what?
There's like text on the right that only shows up when you're hovering that line.
Oh. Oh, you mean this over here?
Yeah.
Oh, that is a, I should probably run this with like all my plugins disabled. I've customized my environment a bit. That is the Git Lens extension. So one of the things that extension does is it adds the Git blame or the Git show stuff. So this text over on the right is saying this line originated, you know, and it's giving us the commit information of where this line came from. So this like entire curriculum, Jake and I have managed this in Git, you know, obviously for at least 3 years now, because this particular line, you know, I wrote it 3 years ago and then Jake merged it, you know, on September 15th. And it just shows you that, you know, at the line by line level. So like the links for the documentation, that was something we got in feedback from the last time we did this. At the end of the class, we always ask for, you can provide some feedback of like, you know, what we could teach better. And that was something that somebody mentioned last time, is it'd be nice to have direct links to all the documentation. So we added that, you know, after the last cohort.
So it's basically ghosts.
Yeah, it's basically just doing you know, we have a Git log, and if you do I don't know if you all have done much of Git yet, if you've covered much of that, but you can ask it to show you like who did what, when, like every single line, and it'll tell you. So what we're seeing here, like on that line 15th of, you know, we're seeing the same thing, more or less, you know, the details of this particular commit. Okay, so
that's funny how it's called blame.
Yeah, Git has a how do we say it's well, it's by Linus Torvalds, and he's also known for having a slightly abrasive personality, might say. and let's face it, most of the time when you're looking up code, you're usually looking up to see who broke this thing, not saying who did this amazing work, I want to congratulate them, you know, because it's just human nature. Okay, so select name comma phone from context gives us this. So name and phone are column values. Lots of times, especially when we're exploring, we just want to say, give me all the columns. So select star from context. Star is a shortcut for selecting all columns. We can also use the table name in front of the column. It's unnecessary in this case, but we can do things like that. And we can also do the star. Now, like I said, that's unnecessary here. Where it becomes useful is when we start working with more than one table at a time. So the next part of a select clause that you'll use most often, or a select statement, is the where clause. So the where clause is a Boolean expression. You're going to hear me use that word expression a lot today, because most places, or many places in SQL where we're just selecting a column or we have a where condition or whatever, those things actually are expressions. And that means we can do things that don't have anything to do with columns. We can say select 1 + 1, and it'll evaluate that expression and return 2, for example. In this case, what does where do? So where looks, when we have a where clause, it looks through all the rows and it evaluates that expression for each row. So I think it's slightly intuitive anyway. Here it's going to return just that one row that matches. But we can see exactly how that works. If we move that expression from the where clause and we put it in the select, now we can see we have a third column there, and F is for false, T is for true. We can see the only row for which it is true is this Sybil Nicholas here, and all the rest of them are false. And when we have that evaluated in the where clause, it's going to only accept the rows which evaluate to true.
What was the command before that?
Which one?
The one to show the true and false?
Okay, that would be what I have on my screen right now here. The select clause.
Oh, okay.
Yeah, usually people think of the select clause as it's just a bunch of columns, but it actually is a bunch of expressions. So the third one we have here is the expression of test for equality between phone and that 579, 804, 9800. So let's do a little exercise here. We want to find the phone number for a particular person. So we are going to have a query very, very similar to this, only we're going to look at name instead of phone. And we're going to look up the phone instead of the name. So I'll give you about 90 seconds to try that, and then we'll go on and give you a chance to work on that. Also, I'll mention that in the directory for each of these lessons, there's a solutions.sql file that has the solutions for all the exercises as well. And if you get done with the first exercise, let's go on to the second one as well. All right, so for that exercise 1.1, we would change the query so it's select phone from contacts, where name equals, Laurie Abshire. Just change the condition. And for the second example, it's actually the same query as we had before. We just changed the phone number. Now, there are a lot of expressions we can use in the where clause, and there's a lot of operators. So one of the operators that's really useful is the like operator. The like operator gives us pattern matching for text. If you're familiar perchance with regular expressions, it's a much simpler, much simpler language than that, but you could think of it as similar. So if we want to find someone and we only know their first name, we can do a like operator, and the percent in the text says match any number of any character.
Is there a like a shorter form of it where it's like you can specify the number of wild characters that you would accept? For instance, say like I wanted Tammy, but only with a last name of like 4 characters long. Could I use like exclamation points or asterisks?
There is. It's much less common to do that, but there is. So like, for example, here, I'll just change this. I believe it's underscores. Yeah. Underscore says match any single character.
Cool, thanks.
Mm-hmm. Yeah, generally, if you end up with something a little more complicated than, simple, this is, to me, like is basically prefix and suffix matching is about all I would generally use like for. I don't know that I've ever used underscores in production. I may have, but if I have, I don't remember it. Generally, if the matching gets any more complicated than that, I would switch to using regular expressions. And then, it ends up being something like, something like that. But like is much simpler to learn because most people just need to remember percent means any number of anything. Whereas regular expressions, that's like a whole language to learn.
Yeah, you can really drill down into it. Cool, thanks.
Yep. All right, let's do another quick exercise here. This should be pretty similar. We're going to have to use like, only we're going to, need to have the match any number of any characters at a different spot in here. So we'll give you, about a minute or so. Look at this. Okay, so this query is pretty much the same. It's just since we're searching for a suffix, we put the match any number of any characters thing at the beginning. Now, by this point, I'm guessing a handful of people are probably really confused because they keep typing stuff into Sql and like nothing is happening. Things don't seem to work right. If not, this is actually a really lucky class because, like I said, almost every, in fact, actually, I think I can say not almost, every time we've done this before, by this point, somebody is really stuck and really confused. And let's talk about that a little bit. So in Sql, I'm going to type select phone. Okay, I hit enter, nothing happened. Why didn't it do something? You know, maybe it's not a complete SQL statement. You'd think it should give me an error message or something. But instead, I can just keep typing stuff here. Nothing's happening. How do I fix this thing?
Oh, semicolon.
Yeah, exactly. So you can enter multiple lines of text and it won't try and execute it until you terminate the command. And it's subtle, but the Sql prompt actually tells you a little bit about that. This is the way it looks at the start of your command. But once you're in the middle of a command, it shows you this minus sign here. So if your prompt has changed shape slightly, that's telling you you're in the middle of something. So in this case, I can just add a semicolon and when I run it, it tells me something's horribly wrong. But it's also possible that you accidentally have a, you get stuck in a string literal. Now this gives us a little different prompt thing here as well. But now this can be really confusing because I can type anything I want here. I can even type a semicolon and nothing seems to work. I can type exit, I can type, quit, and it's smart enough to notice and give me a little hint there, but I'm still kind of stuck. So if you get in that situation, Control-C breaks out of whatever's going on and gets you back to a normal prompt. So like I said, I'd expect probably a handful of people were kind of stuck there. It can usually, whenever something goes wrong and I get stuck in one of those things, I just mash Control-C a few times and usually it gets me back where I should be.
You mean Control-D?
Well, let's talk about that. So Control-C breaks out of your command entry. The Control-D that it's suggesting there, that actually quits Sql.
Oh, I see how it changed now. My bad.
Control-D is actually another one of those things that's really useful to learn though. Control-D is how you tell the terminal to tell the operating system that the file has ended. And Unixes generally, and I guess Windows follows it for command line things, treat everything as files. So Control-D is the end of file character. And that's actually really useful because like if you open up Python and you type, I can't remember which one it is it exit? Yeah, it's so helpful that like, hey, I know what you mean, but I'm not going to let you do it. Yeah, use this other thing instead. But Control-D works in Python. IRB is the Ruby interpreter. Control-D works in Ruby. We've already talked about, we're already in Sql. Control-D works in Sql. If we started a shell in Bash here, Control-D works in your shell as well. So basically any REPL, I don't know if you're familiar with that term, it's REPL. It stands for read, eval, print loop. So it reads your input, it evaluates it, it prints a result, and it does that whole thing in a loop. Basically any shell, any interactive interpreter like Python, Ruby, Sql, those are all REPLs. And Control-D will generally quit any of them because they read from standard in, you close standard in, it says, oh, I must be done. Now, occasionally, like in Sql, you might be stuck, if you're already inside of something, that you've like started to type, you're like, if I type Control-D here, it actually doesn't do anything because we'd need to be at the beginning of a line or hit enter or something like that. But get Control-C to break out of it, then you can hit Control-D. You might also notice it's printing \Q. That is the other way of quitting. Sql has a whole bunch of / commands. They're meta commands that actually are commands to Sql itself instead of typing something that will be sent to the Postgres server. So we kind of dabbled in a bunch of things there. Any questions on that before we go on? Cool. All righty. So the next thing here is another operator, and that operator is ILike. And it is just the case-insensitive version of like. By default, like is case-sensitive, so if you had casing wrong, it would not match. But ILike does give you matches. If we did like, we would get no match.
So I do have a question.
Okay.
So in the real world, like when you're at work or whatnot, what use cases do you normally differentiate or like use ILike versus like whenever you're in production?
Sure. So here's a simple example. You would probably not do it this way at like huge scale. You might actually, but you'd probably do something different at huge scale. But let's say you had a list of users and you're on the sysadmin council for your web application, and you have thousands and thousands of users, and you want to have a search box so they can search for people by name. Well, that's where having a case-insensitive search would be valuable, because like if I just have a search here and I just search for Carrie, well, I don't want to care whether the casing is a little different. In fact, what you would generally do for a search box like that is you would take whatever they type in and you would ILike and you would add the % to each side of whatever they typed. And that would give you your search term of the pattern match. Now, performance-wise, you might not be able to do that if you had an enormous table, but at small scale, this would be an example of that. The alternative, or an alternative, would be using a lower function on both sides. And the lower function does what it says. It converts text to lower. And that's another example of how everything, well, I won't say everything, but many things in SQL are simply expressions. So this where clause we had here, the where clause as a whole is a single expression. It's the left-hand side of like versus the right-hand side of like, but expressions can be composed of expressions. So this is an expression that calls a function. And then so it evaluates like what is name, pass name to lower. Now we have that on the left-hand side. Do the same thing over here. We have a literal value that gets passed to lower. The result comes back here. Now we have the result on the left-hand side and on the right-hand side. So then the like operator compares them and returns true or false.
Okay, yeah, that makes a lot of sense, especially when you're just using a search example.
Cool. Cool. Okay, so that's the basics of selecting. There's obviously a lot more to it. We're going to come back to that. But if we have a single table, we now can select all the columns or any subset of the columns. And we can use a where clause to select which rows we care about. Well, what about inserting rows? So to insert rows, we use, well, the insert statement. And the syntax for this is the keywords insert into. Then we specify the table. Next, we specify which columns we are going to supply values for. Technically, that's optional, but it is usually a good idea. So we say, I want to insert into the context table. I am going to supply values for the name and phone columns. And then we say, well, what are the values? Well, then we use the keyword values, and in parentheses, we supply the values for that row. Now, there's another why question that might be, some people might be thinking, but maybe I know some people just don't like to speak up. So I'll just preemptively maybe answer this why or what question. So what is this insert 01 business that it says? That's kind of confusing, isn't it? Or at least it's like, why? What is this?
Is that like start finish?
Isn't there like 1 row and 0 columns?
So the 1 row, yes. The 0 columns, no. So
Index, like an index of 0, index of 1.
So this is, I won't say this is a trick question, but it's one of those obscurities of history that you're probably just never going to guess. Just seriously. So first of all, that whole thing that comes back is something called the command tag. At least that's what it's called internally in Postgres. And that is the result of, I sent it a command. What did it do? What was the result? So this entire little string here is the command tag. And generally, what it is the statement, what did I do? And then perhaps some additional information. In this case, insert. It's telling us, hey, I inserted a value. Great. What about the 0 and 1? That's a little confusing, though. So as somebody suggested, the 1 is how many rows did I insert? Given that this is our first example, we only inserted a single row at a time, but it is possible through several means to insert multiple rows at once. So if we did that, if say we inserted 10 rows, then it would say insert 0, 10. But that still leaves us with the question of what does the 0 mean? And in this case, what does it mean? It means absolutely nothing. Really. It used to be in old versions, like really, really, really old versions of Postgres, like it's been this way as long as I've been doing it. And I've been working with Postgres for, 13 or 14 years, somewhere around there. Way, way, way back, probably back into the 90s would be my guess, maybe early 2000, maybe really early 2000s. It returned something meaningful about like the internal ID of the row or something like that. But Postgres has long since moved away from that. But the problem is, what if an old program that was designed to talk to Postgres expected that whenever it inserted a value, it would get the word insert, then it would get a number, and then it would get another number? Well, if Postgres changed the result it gave back, it would break those old programs. So to preserve backwards compatibility, they always return the number 0 just to make sure that it keeps the same format that it's had for the last 20 or 30 years. So literally the 0 means nothing at this point. But the 1 is important because that tells us how many rows were inserted. All right, let's try inserting a record without a phone number. All right, wow. It doesn't like us trying that. So let's look at this error message. Null value in column phone of relation context violates not null constraints. Detail failing row contains John Locke null. Okay, so there's a lot of jargon in that might be unfamiliar. So the first bit of jargon here that might be kind of glossing over or wondering what in the world is this, of relation. What is it talking about relations? So I think the common stuff people think of when you say a relational database is we kind of think of joins, we think of multiple tables, well, relating to each other. But that's a little bit of a misnomer. The relation part of a relational database actually goes back to mathematics. And it's the mathematical concept of a relation. You don't really need to know any of that necessarily to be very effective at SQL. But a lot of the terminology goes back to that stuff. And SQL wasn't entirely successful at this relational idea of data management. But if you look back at a lot of the early literature, the early people in the 70s who were designing and building these ideas, it's quite mathematically oriented. And the relation term comes from that. Generally, we can, yes, the 70s. I think the first version of it was 74-ish, something like that. And it was commercial products by the late 70s. So like I said, this is a very old language. And that's actually, it has its good parts and its bad parts. The good parts is this is going to be around for a long time, most likely. The bad parts is the syntax can be a bit clunky. Like people wouldn't generally write or wouldn't design a language with the syntax of SQL anymore. But it's not bad, just a little crusty. But okay, relations. So we can think of relation as, if you want just a common vernacular, like understanding of it, a relation is a table, a view, and that's pretty much what people will mean. So violates not null constraint. So null, that's another super fun one. We're going to spend a while talking about that specifically in the lessons in the future. But for now, we're just going to say null means empty. It actually means a lot more than that. But for now, we're going to say it's empty. So constraint, what does that mean? Well, let's look at this table definition. So we're going to run one of those backslash commands, \d. And we're going to say \d contacts. Now, \d means like describe or display. And it tells us, we give it a name of a relation in the database, and it'll show us something about it. So it's going to tell us about this table, public contacts. Public is another thing. Postgres has the idea of what it calls schemas, which you can think of as if it was a file system, you can think of it as a directory that tables go in. As with most everything we're going to talk about today, there's usually more to it, but that's the simple way of looking at it. And we can look here and we can say, oh, we have a name. The type is character varying. Collation, we haven't specified a collation here, but what collation means is the sort order. So, in English, B comes after A. And, we all, learned the alphabet in school and, we have A to Z and whatnot. But some languages, even some languages that use, the Latin alphabet, they have different word orders, or they have different letter orders, especially if they have, I'm blanking on the word for it, but we have like two letters together that act as one. I'm blanking on the name all of a sudden. I think German has a few of them, for example. Sorry, I can't think of the name of that. But the short of it is different languages have different rules for sorting. And we can specify those different rules in the database. Next, nullable, we're saying it's not null and that we don't have any defaults for these. So constraints, that's a really cool thing that databases provide for us. When Jake was showing us around a spreadsheet, we were talking about its its inadequacies, its certain inadequacies. One of them is it has limited abilities to guarantee data integrity. Postgres is designed to provide a lot of systems for that. And the simplest, or one of the simplest of them, is nullability constraints. So we're going to say this is a contact list like we have in our phone. Well, we've got to have a name and we got to have a phone number. So we will tell the database this column must not be null, period, end of story. And the database will simply not let us insert or update or however wise violate that rule. All right, here. So yeah, in the documentation here, we're saying, yeah, one of the meanings of null is empty. We'll talk about the other ones. So that's the basics of the insert statement there. We are going to see, it's been about an hour now. So we are going to take a 9-minute break here. So we'll break till 10 after 11. Then we'll do another 50-minute segment before lunch. And we'll continue in 9 minutes or 8 minutes now with the update statement. All right, can y'all see my screen again?
Yes, sir. Looking good.
Great, great. So the next statement that we're going to talk about is the update statement. And we have an example there. It starts with the keyword update. We tell it what table do we want to update. Then the keyword set, and we have a comma separated list of column equals new value. In this case, we're only specifying one, so there is no comma separated thing, but we could specify multiple ones if we wanted. And you may have noticed as I'm typing some of these out that I may or may not use spaces the exact same way. Like most any language nowadays, it's space and, well, I say that, except for Python. Like most languages other than Python, it's space insensitive. You're using Python now, right? Is that what this cohort is?
Yes.
Yeah.
Yes, and J.
Cool. Yeah, when Jake and I first started teaching with Alpha Platoon, the first couple platoons used Ruby. All right, so as another aside, the right-hand side of the phone equals part, that is also an expression. So we could have, just an arbitrary, expression to be evaluated there if we wanted to. The update statement here. So the command tag that comes back says update. So we know what we did. We did an update. And this one is a little simpler. It just tells us how many rows did we update. All right, so let's do this quick little exercise here. I'll just kind of do this along with you here so we can get going a little faster here. We're just going to change John Smith's phone number. So in the where clause, we're going to look for John Smith. And I'm going to change the phone number here. And again, it tells us we updated a single row. Now, here's an interesting thing for us to try. What if, say we mistyped this here. If we run this, is this an error? Well, that kind of depends on what you mean by an error. As far as Sql is concerned, that was perfectly valid. We told it to update all the rows where name equals John Smith and then my mashing the keyboard. And it did. It just so happens there were 0 rows that met that criteria, so it successfully did nothing. That is something to think about when you're doing whether a select or an update or a delete, where you have a where clause. Selecting 0 rows is totally valid. Same thing as this. We can say select from contacts where name equals something here, and that's fine. it found 0 rows. That's a perfectly legitimate answer. But that is also why it's useful to look at this updates, command tag that came back. It's like, oh, it didn't update anything. That might be useful for us to know. And most of the time, you don't have to, when you're using an ORM, like Jake mentioned, the object relational mapper, which I believe, not sure what the name of the one you'd be using in Python is. Was it SQL Alchemy maybe? Or I don't know if Django has a built-in one, but.
I think it's Django ORM, if I
Okay.
recall.
Okay. Generally, that will handle things like checking the command tag for you automatically. So if you try and update a record and somebody deleted it out from under you, for example, it'll probably tell you that. But yeah, update, fairly straightforward.
Got a quick question.
Sure.
So when we're doing the update, I noticed that the name Simone Bear jumps to the bottom, and there's not really a set order for things. We recently went over data structures, and I was just wondering, like, as far as how SQL handles the memory storage in the computer, just how that is considering everything changes around.
Okay. Well, now that is a very fun question. That is the type Y questions I was hoping somebody would answer, because they're a lot more fun to answer than how do you do a particular type of select statement. Okay, so to answer that, let's start by picturing how this data could be stored on the hard drive. And that's going to tell us some of what the database is actually doing for us. So I don't know how many of you remember old school printers that, like, the paper was all on a spool, and you didn't have 100 sheets of paper separated. You actually had 100 sheets of paper connected, and you could print banners for it. But if you wanted individual sheets, you had to tear that weird stuff that the spooling went through on the sides. You had to pull the stuff off the sides, then you had to pull the pages apart. Anybody remember or seen that type thing? You know what I'm talking about? No?
Yeah.
Oh man, I feel old. Okay, so, well, okay, think of like a scroll then. Like, we'll go really old school, like something, like an ancient monastery or something they would be writing in a scroll. And this scroll might be 20 feet long or something like that. Now, let's say we have 20 feet of a scroll, and we write down a bunch of stuff, and we realize, hey, right in the middle of this, I need to insert something. How do I do that? I mean, really, how would you do that?
Rewrite the whole scroll, including like the change, and then pick up like the old stuff?
Yes, actually, that's, you either have to do that, or maybe you cut the scroll in half and sew it back together or something. If it's made out of animal hide or something, maybe you could do that. But the analogy holds there. That's actually like a really hard problem. Well, that type thing kind of applies for a database as well. Say we have a gigabyte of data. It's a list, or multiple gigabytes. We have a table that's, we'll say it's the Social Security Administration. We have a list of like every worker in the United States. And somebody changes their name. John Smith changes their name. And instead of Smith, if we're lucky, maybe they changed their last name to another 5-letter name. But what if they changed it to, a 12-letter name? There's no room for it there. How do we insert that new data? That is a hard problem at scale. I'll tell you, at small scale, what you do is exactly what was recommended for the scroll. You rewrite the whole thing. So you load the whole file into memory, you change it in memory, you write the whole file out. But obviously that works at the small scale. It does not work at the large scale. So at the large scale, we have to be a little more clever about how we do this type stuff. So the approach Postgres takes is Postgres has organized all the data into what they call pages. And those are 4 or 8K. I'm blanking on which size it is at the moment. I think it's 8K actually, but it's actually a compile time config thing, so it's actually not set in stone anyway. But they have fixed size pages that all the rows go in. And what they do is when you need to write a new value, they may just put it in a new page. And there is no ordering. So unless you say, unless you had an order by clause, which we haven't talked about yet. But for how this actually is represented, there are a bunch of hidden columns in Postgres. We're going to look at a few of them here just for kicks. So OID is for object ID. That tells us which table did this come from. Well, they all came from the same table, so that's pretty self-explanatory. Xmin, Cmin, Xmax, and Cmax, those are internal records that determine when this row was inserted, when it was updated, when it was deleted. We haven't talked about concurrency much, aside from in Excel saying having 20 people working on the same thing at once isn't going to work. In a database, it can, or it does work, but how? What happens if while I'm busy doing something, I delete something while you're looking at it? Well, one of the things it does is it keeps basically a separate view of the world for each person that's using it at the time. They use something called transactions to allow you to get a consistent state. So I can start looking at something, and then if you delete it, it still looks like it's there for me, or it can, depending on if you use the correct transaction level. So these columns here of Xmin, Cmin, Xmax, and Cmax, they tell us, or they tell the internal system, when did this thing become visible? And for rows that have been deleted, they also say when this row was deleted. Now, that to explain that a little further, when we update a row, there really is no update in Postgres. There is a delete and a new insert. So when we update a row, what it actually does is it marks the original one as deleted at point X in time. Now, time here is like a transaction ID, which we don't really need to, that's like way, way down in the weeds. But it basically marks it and it says after time X, this thing is no longer visible. So if I'm still looking at it before time X, I can see it. But if you're after time X, you can't. And then it inserts a new row that says, I just first came into being at time X. So if I'm before time X there, I can't see the new one. Okay, so if we scroll down here, these ones that we updated, we can notice that that Xmin, which is the transaction at which it first became visible, we can see those ones we updated. Every time we update it, it goes up. So like John Smith ends in 42 there. If I rerun this update, I look at this again, that transaction ID just went up by 1. Now, the other thing that's interesting here, and to finally answer your question, I know this is kind of a long way around, but that last column of that CTID, what that is the physical location that this row exists on disk. So we talked about that everything is broken up into pages or blocks, and then within a block, multiple rows can be stored there. So this, as far as this table is concerned on my computer here, this is stored in block 0, it's row 23. And because it kind of just added it to the end there, because it has to, because it actually just marked the other one as deleted, it didn't actually remove it yet. This means that when it reads it on the drive, it literally is at the end. So this is actually way down in the weeds of how it actually works, but I think it's pretty cool. And there's actually a command you don't, this is a sysadmin thing. This isn't something you'll really run as a programmer, but this tells it to basically to compact all the tables. Because just like you have garbage collection in Python, where when you stop using a variable, eventually it gets cleaned up. This type of database basically needs its own garbage collection process when a row that's been updated or deleted actually physically gets removed from disk. But to do that, it has to do that process of rewriting the whole scroll. Or in this case, I told it to rewrite the whole scroll. Sometimes it's incremental maintenance. It'll just rewrite an individual block. So we might think of that in that analogy of our database is made up of a lot of, 5-foot scrolls, for example. Instead of having one scroll that is, 20 miles long, we have a bunch of small scrolls. And with having done this vacuum to compact it, if we rerun this thing, we'll see that those holes in the which row number is this within the block, those holes went away.
Okay, that makes sense. So just for me to think about a little bit, say Facebook, it has all of the data entries that it has. If you were to do that vacuum full because of changes and things like that, people could still look at the different data entries as it's doing the vacuum full. And then after it finishes that, then it changes at that moment. I'm just wondering for like bigger data sets like that.
So for a really big data set, you actually would never, well, I say never, you probably would never run that command because that locks the whole table, or in this case, it blocked the whole database because I'm doing it on all tables. So Facebook could never do something like this.
Okay.
And these extra columns that I'm showing here, like I have never had to do anything with these in production, ever. This is more informational stuff that kind of peeking behind the curtain of how the system actually works.
Got it. Thank you.
And there is a auto vacuum process. That's why I was saying that kind of incrementally does stuff in the background. So under most cases, unless you're a really big company with a lot of inserts and updates and deletes going on, you just won't ever need to worry about any of this, but it's under the curtain. That's how it works.
Thank you.
You're welcome. Good question. Any more questions before we move on to deletions? All right. Well, delete is fairly straightforward as well. We say delete from, then we tell it which table. Then we give it a where clause to say which row do we actually want to delete. And the command tag is similar. It tells us this was a delete, and it tells us how many rows we should have deleted. Now you'll notice on line 67 here of the notes, talks about, it is really important that you have a where clause on your updates and delete statements. Because guess what will happen if you don't do that? If I forget to add the where clause, it's all gone. So yes, be very careful with those. And you may have noticed that I ran begin first. So we'll hopefully get to talk about transactions more this afternoon. But begin is how you start a transaction. A transaction is an atomic group of work, atomic being, indivisible. Either it all happens or it all fails. And if something goes wrong, it'll roll back the whole thing. Or we can just tell it roll back the whole thing. So given that I kind of just deleted my database here, it's really nice that I can say rollback. And it goes back to where I started from begin.
Is there a way to stop? Like, is there like an ending to the begin statement?
Yes. So if we did do something that we wanted to take effect, I guess I already deleted this one, but we'll say this deleted it. When you say commit, that finalizes it.
I was just about to ask if this was like vaguely Git like for SQL.
Yeah, I guess that word is used for both of them. Well, actually, the thing that's similar about SQL and Git is they're both like really sharp tools that it's easy to cut yourself with, actually.
Sorry, real quick, can you go over that rollback command again? Would it be just rollback in the line that you wanted to call back, or was it just like the keyword in general with some sort of a suffix?
It's just the word rollback, because where it goes back to is when you started begin. So that's actually one of the dangerous things about SQL is if you did not start a transaction, there's nothing to roll back to. So if I run a rollback now, it's going to warn me saying, hey, there wasn't a transaction to roll back. So that's one of the toughest things with SQL is we're used to nowadays, we can make changes, we can just hit Command Z or Control Z a few times and undo stuff. There is no undo here. The only way there's an undo is if you purposely say, hey, I'm about to begin doing something, and if something goes wrong, I want the ability to step back. But otherwise, it's fire and forget. It immediately takes effect.
That is kind of sketchy sometimes, eh?
Is it possible to like have multiple begins that you can roll back to, or is it only like one? So you have like a begin, you do your transactions, you close it, and you can either roll back out of that or not at all. Or can I go back to a begin 3 begins ago, for instance?
It is possible. It's with a slightly different keyword, but what we have is something called a save point. So I'm gonna insert another row here. Oh, and here's another thing. If you're in a transaction and it fails, it's not going to let you do anything until you get out of that transaction. Let's see here. So I'll insert another John Smith II. Now, the other command is a save point, and you name it something. So I'll just say S1. And I'll insert John Smith III. At this point, if I look around, both of those are in here. But I can roll back to that first save point. And now that third row we inserted is gone.
Is there a way to list out to see all your save points?
That's a good question.
Just in case you forget it.
Yeah, to be honest, I don't know. I suspect there is a way. Postgres has like maybe 50 or 100 internal views that you can select from and get like internal information, like yeah, 131 possibilities, good grief here. So it wouldn't surprise me if one of these actually does that, but I do not know off the top of my head which that would be.
Google says apparently not.
But yeah, there's a ton of internal stuff where you can ask the database questions about itself. And yeah, I'm 90% confident that one of those 131 tables or some combination of them will answer that question, but I don't know what it is. And in general, you wouldn't need to ask that question though. If this is, the only place you would ask that is if you're interactively working in the database, and you generally would not do that against a production system. And if you're not working interactively, that means you're using, a program to do it. And the program, your code would say, okay, I'm going to start save point S. Well, the code is going to know, roll back to S or commit or whatever at that point. So, and I'll be honest, even save points are fairly rare to use in production code, at least in my experience. I use it fairly often interactively to develop stuff, and I just end up using, you know, S1, S2, S3. And it's basically when I have a long sequence of things where I'm going to make a mistake and I don't have to retype or rerun everything. You know, I got 20 statements. I want to have a checkpoint. So if I do something wrong on 21, I don't have to rerun all 20 again. Okay, so we covered delete there. Or any more questions on that? I mean,
That's
having
all right. You go ahead, go sir.
I was having a bit of trouble understanding how the whole begin and commit correlate to what you're doing.
Okay, so begin is basically saying, I want a checkpoint here that I can go back to. So we have to, it doesn't automatically make these checkpoints. So we have to tell it ahead of time, hey, I'm about to do something that either all needs to happen together, or I'm worried something is going to go wrong, or I want to try something, but I don't want it to be permanent. So I'm going to use begin because that's going to say, I want to start a checkpoint that I can always go back to. And then commit says, I like what I did, make it permanent. Rollback says, I don't like what I did, make it so it never happened.
Okay.
Cool. Okay, so next up is the order by clause. This actually kind of goes back to our little dive into how Postgres stores stuff on disk. You know, we made some updates and all of a sudden the orders were different. You know, what's up with that? Well, we dived into that a little bit so we can actually kind of see where that stuff came from. But obviously that is completely unknowable to us, you know, oh, somebody changed a record, so now stuff comes back in a different order. We don't want that. So the SQL language defines, you know, it's explicit. If you do not specify an order by clause, the order that it's going to be returned in is undefined. Now I say undefined there specifically rather than non-deterministic because, you know, it is a machine, you know, it is deterministic. It will always do something, you know, that if you understood the entire state of the computer and you understood the entire Postgres source code, it is a deterministic result. But we don't understand the entire state of the computer, and we certainly don't understand all the Postgres source code. So it is unpredictable to us. You know, it's undefined. There's no guarantee what's going to happen. If we care about the order, we have to tell SQL, I care about the order. And the way we do that is by an order by clause. So we can say select star from context, order by name, and it will sort it by default in ascending order. And we can say ASC for ascending if we want to specify it for some reason, even though it is the default. But if we really wanted it the other direction, well, we can say descending. Fairly straightforward. Again, this is another place that we use expressions. So for example, there is a function that gives us random numbers. So if we really wanted to get orders in or we wanted to get rows in a random order, we could even do this. Now, just FYI, if you ever need that, that's going to be slow on a very large table. There are better ways of doing that, but just by way of example. All right, so along with order, we also typically use the limit keyword. So this is the type thing. Okay, we talked earlier about like, what if we're searching for a list of users and we might use the like operator? Well, if we have, you know, hundreds of results, maybe we don't want all the results at once. Maybe we want to limit the results. That often would go with order. Sometimes it would just go by with a where clause. But actually, almost always it would have an order clause as well. We can just say, give me X number of rows, limit it to 5 rows. Now, one other thing we can do, if we were to do pagination, I don't think I actually have this in the notes here, but this is a freebie. Let's see, where did this, there. We also could say offset, and we can say how many rows to skip. So I'm going to skip the first 2 rows here, and then limit it to 5 rows. Now we've covered the basics of select, the very basics of select, insert, update, and delete. Let's talk a little bit about table structure now. So the first thing here is, for simplicity's sake, we purposely didn't actually build these tables exactly right. There are some more things we should have done. So the big problem here is, how do we tell rows apart? It's entirely possible for people to have the same name. It's entirely possible for people to have the same phone number. We need some way of telling rows apart. So a unique identifier. In SQL parlance, a unique identifier is called a key. And we should always have, at least, I say always, I mean, relatively speaking, we should always have a unique key for a row. Or we should have at least one unique key. And the most important unique identifier is called the primary key. Go figure, the primary one. And like I said, with very few exceptions, every table should have a primary key. So we are going to run this command here. And I know this looks like a whole mess of jargon. And this type command, I've been doing it long enough now that mostly I know the syntax, but it was years of looking stuff up. And I still look stuff up fairly regularly for the more esoteric commands. So for this type thing here, I wouldn't even recommend trying to memorize, oh, well, how do I add a column to a table? When you need to add a column to a table, you're going to Google something like Postgres add column to table and find Stack Overflow and see what it says. Just being honest there. I mean, it's not, there's so many like little details, it's not worth memorizing. You know, maybe if you're really ambitious, you'll go straight to the Postgres docs instead of Stack Overflow. And the Postgres docs are really good, so that's not a bad idea. But for an explanation of what this is doing, we can talk about, oh, did I mistype that?
I think you wanted to add column, not alter.
Oh, yeah. Yep. My bad.
And I think generated is spelled wrong.
Oh, yeah, man. Okay, cool. So for the syntax of this thing, we say alter table, and we have to tell it what table. Then we can give it a list of changes to make. This command lets us make multiple changes at once. So the first command is we're going to say add a column. It's named ID. Then we have to tell it what type of column it is. So that's something we kind of glossed over. I know like in Python, values have types, but variables don't. And this is a little different. So variables or columns or values or whatever, everything is typed. And in this case, we're saying the type is an integer. So in Postgres, integer is a 32-bit integer. If you need a 64-bit one, you can do big int. And again, for like the mathematical roots of all this, you can think of a type as the set of all possible values that are allowed. So like for this one here, there are approximately 4 billion allowed values for ID and no other ones, because we have a signed 32-bit integer. This incantation here basically says we want it to be auto increment. Auto increment would be a lot nicer of a word to say. But this is what the SQL standard decided. And the SQL standard is not known for being necessarily overly concise, shall we say, in its commands. So you may also see, if you look at older material, you may see something like this. That is Postgres specific shorthand for saying it's a 32-bit integer that is auto increment. For various reasons, this should be preferred nowadays. One, it's SQL standard stuff. And two, there's some weird things where if you like copy a table in various manners, it will it'll do what you expect instead of having some surprising behavior with your incrementers. So this is another one that this is kind of an incantation. You kind of just need to look up until you've done it a bunch of times. Then lastly, we tell it this column ID is the primary key. Now, generally, you're going to use one column as a primary key. In fact, most of the ORMs that you use almost insist on it, in Ruby or Python. But at the database layer, it's perfectly fine to have 1, 2, 3, 4, however many columns combined be a key. Let's see here. Let's see. So we added this ID. Let's take a look at the table. Right. So we now have an ID that'll work regardless of regardless of if we have names that are identical or phone numbers that are identical, the ID will work. All right, so let's create a table. So the idea for this phone book thing is kind of like the phone book on your phone. You keep track of contacts, but it also keeps track of when you've talked to people. So we're going to run this thing, and this is one, probably just go ahead and copy and paste this one. We do like to type things mostly, but this is starting to get a little longer. And most of this we've seen before. If we're creating a table, we can mark something as primary key right in the syntax here, and we can do all this together. And again, the syntax for this stuff is, if you do it enough times, you'll start to remember it, but otherwise, just Google it. It's not worth trying to memorize. But we're going to have an ID. Each call will have an ID. We will have a contact ID. So a call belongs to a contact. So, if we talk to John Smith, we're going to say contact ID is 19. And we're going to say we must have a contact for that. It's not null. Then here we're going to say call start. When did this call start? The type is going to be timestamp with time zone. And how long did the call last? That's going to be an interval. All right, so another fun discussion, or kind of getting into the weeds. So we talked about timestamps there. We talked about durations. So times are one of the most annoying things to deal with as a programmer or as a database developer or whatever, because we think we know what it means, and we do have a working understanding how it works in our life. But if you actually boil it down to it, like when we say, what is a time? we're going to go to lunch in 11 minutes. I'm looking forward to it. I'm sure everyone else is as well. So what is a time? Any quick definitions we might be able to use there?
You talking about time as far as coding, because I'm pretty sure it starts in the 70s, but
Sure. So you're talking about Unix time starting at 1970. Yeah. So that is kind of a detail of like how it's implemented in Unix. In Postgres, interestingly enough, the epoch, as we would call it there, actually starts at Y2K. That actually has no bearing on anything we're going to do, but just for curiosity's sake, it's a 64-bit integer, that's signed, so it can go before Y2K, and it can go after if it's positive. But a time, we might say it's a point in time. It's the when an event occurred. I mean, it's hard to define that without being self-referential. But an instant might be another word that we would say. So, okay, so it's an instant in time. Well, okay, so 12 o'clock. Well, there's a lot of 12 o'clocks. Would we say that a time includes a time zone? And I guess when I'm saying time here, I am meaning including a time. So, right now in my time zone, it is June 22nd, 2021, 11:50 a.m. So that's what I mean when I say time. I always am including a date there. I'm not talking about specifically time of day. So a full time of like date and time, does that need to include a time zone?
yes.
I would think so.
Yeah, because otherwise, well, there's how many different time zones? We don't actually know. If we want to record the exact instant something occurred, we need to know, either we need to know what time zone it happened in, or it needs to be converted to a known time zone. But we need to have one of those. So, okay, so that's pretty clear with times, because like if we say, oh, it's 11:51, well, in Greenwich time, it's what, we're -5, so it's like 4:51, I guess it would be now, something like that.
Correct.
So, okay, so we figure times probably need time zones. What about dates? It's June 22nd. Does that need a time zone?
I would say yes, because you have the international date line, and then it could be yesterday while it's today for us.
Exactly. Yeah, the time, you got the date line. You also have, if you say, okay, this, bill is due, or this, my subscription expires, or this contest ends, or whatever, at the end of day. Well, the end of what day? Every time zone potentially has, a different time the day ends. So yeah, dates would need time zones. What about this? Can time go backwards?
I'm gonna say no.
No?
I was gonna say technically yes, depending on what time zone you're in. If you're in a time zone that's, let's say, for the east, you're trying to get a time in the west, technically you're going backwards.
Relative to you, yes, but relative to the world, no.
Well, if you have daylight savings time, time will move backwards when that clock's roll back.
Are we talking about just time in a machine? What about in your head? 'Cause you can make time go backwards. You just have to figure out how to do it.
Yeah. I guess to be more precise, we're not talking about physical reality. We're talking about the numbers that we say represent that. Can those numbers ever go backwards? And I heard somebody say something about daylight savings time. And that's the most obvious one. There's actually, there's even more than that. It gets really, really fun. But yeah, spring ahead, fall back. So time can go backwards. It can be, 2 a.m. and then it's 1 a.m. again. That also means the same time can occur twice. So that type stuff means that's more examples of why we really, really need time zones, or we need to convert to a unit of time measurement that never goes backwards, or we say never goes backwards. Fun fact, there's also something called leap seconds. So because of the slowing of the Earth, there also are occasionally like 61-second minutes. And mostly we don't need to worry about that though. In general, computers just say, we're not going to care about that. They do something called like time blurring, where they just kind of mash it in, and they never actually have that like extra second. You know, they never have second 60. But there was an instance maybe 4 or 5 years ago, maybe a little longer now, where I believe it was Cloudflare had an outage caused by a leap second. Cloudflare does pretty good write-ups of any like issues they have. So if you ever want like a real interesting technical write-up of a really obscure underlying issue that caused big problems, check out their leap second thing, because it caused them, you know, some, I don't know if it actually was downtime or just some internal problems, but it caused them a lot of problems. Next, do all dates and times exist? I think you're probably getting the pattern here of everything we hope is true tends not to be true. So yes, not all dates and times exist. You know, when we, again, time zones, if we jump ahead an hour, there was like an hour in local time that never existed. And in history, if we go back in time, there's been multiple calendar systems. And if you look at when we changed from, what was it, the Gregorian calendar, I guess it was, in the Middle Ages, they switched calendar systems. And the Pope was involved, and not everybody liked the Pope. So not only do not all times exist, but or not all dates exist, but each country changed from the different calendar systems at different times. So you actually need to know where you are to know, you know, oh, well, these 2 weeks don't exist because they changed in the 1600s. And then somebody else that changed later and like, oh, these 3 weeks don't exist. Or it's really, really messy if you go back there. So all of that to say, time is really, 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 really terrible. And you should avoid doing anything outside of standard libraries and be very careful about assumptions. Like a long time ago, I worked on a time clock thing, and lo and behold, I made the horrible mistake of thinking a time or a day was 24 hours. Well, time zone changes came along, or not time zone, daylight savings time came along, and I had, you know, people's time stuff was off by an hour because I had just said, oh, advance by 24 hours instead of advance by a day or whatever. So that stuff is really terrible. And all that ties back to us using the timestamp TZ thing. So in yet another horrible thing though, timestamp TZ is short for timestamp with time zone. And it would be logical to assume that a timestamp with time zone, you know, had a time zone, right? I mean, that would be my assumption, but that's not what it means. It actually does not have a time zone. What it means is it internally converts to UTC, and it automatically converts to UTC on the way in, and it converts to whatever your local session time zone is on the way out. It's what we want to do, but if you're thinking I can save it here and I'll know that this person was in central time zone, for example, you don't have that. But it does save the exact instant something occurs. So yeah, times are terrible. Use timestamp TZ all the time, basically. They do have a non-time zone aware version of it, just called timestamp. You really don't want to use that under normal circumstances. Interval, this is another fun one. You know, if we were to say, you know, how many seconds is it? How many seconds is a month? Well, obviously months have different numbers of seconds. Days, we already talked about days have different lengths. So if you're going to be doing calculations like 3 weeks from now, you know, exactly from now, you need a type that actually handles all those things internally. So the duration type actually keeps track of like number of seconds, number of days, and number of months. And then when you apply that to a specific date, then it can figure out, okay, well, I know I had 27 days and I'm starting from here, so I actually know how long those days were. Anyway, again, pretty terrible. Okay, well, with all that, let's just look at this thing. We're going to insert a record here. We'll just copy and paste this. You'll notice the syntax for the interval is actually pretty nice. We can just spell it out, 3 minutes, 23 seconds. And the timestamp stuff is standardized as well. We could include a time zone indicator here if we wanted, you know, some sort of like offset. Or it might be T, I can't remember the exact details there. But you generally don't need to, because it will convert from your local time zone automatically. One new thing here is when we have that auto-assigned primary key, it would be nice to know what the ID was. If we add a returning clause, returning basically acts like the select clause of a select statement, and it'll tell us, you know, we can return any of the values. We can even return expressions. But generally, it's usually used simply to give us back the primary key. So every time we run that, it'll tell us, you know, what was the ID that was generated for us. We can insert multiple rows as well and get the IDs back for each of them. Here's also an example of where we said if we inserted multiple rows, it will tell us how many rows. Here we got the insert 02. All right, well, it is noon or 1 minute after. So we are going to break for lunch until 1, and then we will continue after that.